In this video, we'll talk about how to find the radius given the arc length and central angle. So we can use the following formula to find the radius. S divided by theta, where S is the arc length and theta is the central angle. So let's work through a couple examples. Let's say we're told the arc length of a circle is 200 centimeters. And let's say we're told the central angle is 30 degrees. And we want to find the radius. So if we want to visualize this, we have a circle and we're told the central angle is 30 degrees and the arc length is 200 centimeters, and we want to find the radius, r. So the way that we do that is we just plug these numbers into the formula. So r is equal to 200 divided by 30. Now here's the catch. This formula assumes that this theta is written in radians. So right now it's given to us in terms of degrees, 30 degrees. To convert that to radians, we need to multiply by pi over 180. So really we've got radius is equal to 200 divided by 30 pi over 180. Now we can reduce this 30 pi over 180, so 30 will go into 186 times. So we can actually just cross this out, make it a 1, cross out the 180 and make it a 6. So what we've got is the radius is equal to 200 divided by pi over 6. So let's rewrite this down here. Let's say we have 200, we'll write it as a fraction, 200 over 1 divided by pi over 6. Now remember, when we're dividing fractions, that's the same as multiplying by the reciprocal. So we can actually write this as 200 over 1 times the reciprocal. So we flip the numerator in the denominator, 6 over pi. And now we can multiply straight across. So 200 times 6, that's 1,200. And 1 times pi, that's just pi. So our final answer is 1,200 over pi, and don't forget our units, that's centimeters. That is the radius. Now if we punch that into a calculator, we would get something like 381.971 with a bunch of other numbers after it, centimeters. If you would rather view that as a whole number, excuse me, as a number with decimals. Let's try one more example. Let's say we're told the arc length is 50 meters and the central angle is 90 degrees. We want to find the radius. So if we want to visualize this one more time, we're told the central angle is 90 degrees and the arc length, this arc length is 50 meters. And we want to find the radius, r. Well, to do that, let's just plug these numbers into our formula. R is equal to the arc length, 50, divided by the central angle, 90. But remember the catch. This central angle has to be written in radians. Right now it's in degrees. So to convert it to radians, we multiply by pi over 180. So we get the radius is equal to 50 divided by 90 pi over 180. Now we can reduce this fraction, 90 pi over 180, by recognizing that 90 will go into 182 times. So this can become a 1, denominator can become a 2. So we've really got 50 divided by pi over 2. So let's write that right here. 50, we'll say 50 over 1 divided by pi over 2. And remember, when we divide fractions, that's the same as multiplying by the reciprocal. So we can actually write 50 over 1 times 2 over pi. So multiplying straight across, we get 100 over pi. And don't forget our units, we're working in meters in this example. So 100 over pi meters, that is the distance of the radius for this particular circle. And if we punch that into a calculator, we would get something like 31.8309 meters. So that's our radius.